Hi, good morning. I am Sujay Kotwale, Curriculum Data Scientist. This is a sample recording for the program Minor in AI, IIT Roper. Our presentation will be about housing prices prediction. Our topic discussion will be focused on the problem statement, data description and its pre-processing, and the probability concepts behind all machine learning algorithms and the application part of it, how we can apply the probability concept for in our housing predictions. The machine learning models, we will discuss linear regression, decision tree, random forest, gradient boosting, XGBoost. Our findings will help us to evaluate the models, like which model is performing best in our accurate house prediction prices, and will see the implication, like if you are a real estate professional, so how the data driven decision will help you to make informed decisions in investment or in purchasing any houses, and we will discuss further in our presentation. So our problem statement is accurately predicting the houses prices in Delhi region is a complex task due to numerous factors that influence property values, such as parking slots, how many bedrooms, bathroom it contains, or what's the locality, what's the address of that, like which landmark is nearby to it, and so on. So our objective is to develop a robust machine learning models that can predict housing prices in Delhi region based on comprehensive set of relevant features, and we will identify most significant factors influencing housing prices in Delhi region, and we'll also gain insights about the underlying patterns and trends in local housing market using probability concepts and statistical modeling techniques, and we will help a real estate professional to take informed decisions. So our project goal is divided into model four categories: analyze, model, verify, react. So first we'll find the patterns that are responsible for the house prices. Second, the models, like creating the regression model that predicts the likelihood of house prices being affected, like which uh, factor is more impacting the prices of houses, and then we will train the data, and then we will validate and then test the models using various performance measures, and on the basis of the results we will make the informed decisions about housing investments. So data description: data contains 7,738 records. It's containing the property of various regions of Delhi, and it has 18 attributes such as address, area, how, like whether it's having parking or not, how many bedroom does it contain, how many bathrooms does it have, whether it is having a balcony or not, or how what's the price for the 1 square feet, and so on, and the type of building and much more about. So data description, like first we'll see what type of data we contain. So we are using a Python for data analysis, and you can see in the image that we have uh, described our data, and we have seen that we contains prices, address, object, latitude, longitude, and so on. And as you can see, uh, it's also showing the type of the data, like whether the price is float or integer type or object. So it's showing the float, so it's having a numerical decimal value. And as you can see in the address part, it's showing the object, so it can contain a string value or a numerical value. It can contain any type of data, and so on. So for understanding purpose, we are plotting the data distribution plots of the price, area, latitude, longitude, bedrooms, bathroom, and so on. As you can see, the data is some data is rightly skewed, some is left skewed, some is having a normal distribution curve. So what is this all about? And we'll try to understand this, all the concepts through probability. So basically probability is of two type, probability distribution is of two type: uniform distribution and normal distribution. What is probability distribution? It illustrates the likelihood of various outcomes in random process. So what is random process? The processes which are not certain, their outcomes are uncertain. So you must have played Ludo in your childhood days. So in Ludo, you have used dice. So in dice, there are six numbers from 1 to 6, and all probability of getting any of the number is equal. So it is a uniform distribution. Whereas in normal distribution, if you measure the heights of the person, you will realize that the average height of the persons uh, are the more, and some below the average and some are above the average. So you will get the bell shaped curve. So this is normal distribution where the mean, mode, and median is equal. So in our application part in housing prices, we'll see like housing prices across the neighborhoods, and we can see that normal distribution to model these prices. And we'll try to understand like whether prices tend to cluster around their average or it is widely spread. As you can see in the earlier graph, that the visual representation of price distribution was bell curve in the affluent neighborhoods. Bayesian inferences. Bayes theorem help us to update what we believe about a situation after seeing a new information. So let's say 90% of how all houses in our area are expensive, but you see a small house that doesn't look very fancy. Initially, you might think it is not expensive. However, after learning that most houses in that area are expensive, you adjust your belief that the house is also likely expensive. Joint and marginal probability. Joint probability is a chance of two events happening at the same time, whereas the marginal probability is a chance of single event, regardless of other events. Such as, like, I'm giving a random example that what's the chance of being hot and raining today. So this is like we are considering hot and rain together, so it is a joint probability. Whereas in marginal probability, we are just considering the hot, like just the hot today. What's the chance of hot today, no matter what else is happening in the surrounding. So this concept we are trying to apply in our application part, like to understand how two or more features like house size and the location interact to influence the prices. And we'll see marginal probability to isolate the impact of single features like the square footage, and while ignoring the others like how the square footage is increasing or decreasing or the prices of the houses. And we'll see the visualization of how joint and marginal probabilities explain the price variation in our next slides. Expectation and variance. Expectation is the average value what you expect from a set of data or a probability distribution. Such as if you take five houses of 100k, 150k, 200k, 250k, and so on, the expected price is the sum of the price divided by 5. Similarly, the variance, you spread out, you tells how the values are spread out from the mean. High variance means the prices are very different from each other. If the prices of houses in one area range between 100k to 1 million and the variance is high, if they all around 200k, the variance is low. Calculating the expected mean of house prices for different neighborhood and property types in our case, and measuring the variance to understand the spread of prices around the mean and the price similar to similar or widely different. We'll see in our uh, exploratory data analysis part like how this uh, prices affected from one factors to another factors. Regression and maximum likelihood estimation. So regression, it's a way to predict one value based on the others. It shows how changes in one factor affect the other, as the house sizes is impacting the prices. If large house size is there, it tends to be more expensive, and regression will help to predict the price based on the size of the houses. Maximum likelihood estimation helps the model to best fits the data and predict the model as accurate as possible. In our case, the best relationship between the house size and the price is to make the accurate prediction. Regression lines showing predicted price versus actual price will can be seen from R square and mean square error, and we will further discuss this in our exploratory data analysis part and even in the BI models. Law of large numbers and central limit theorem. Law of large number. As you take more data, the average of your result will get closer to true average of the entire population. Like, I'm taking a general example here. The height of the people in your school or in your college, eventually your average will get very close to the average height of all the students in your school or in your college. Whereas central limit theorem, it take a lot of random sample and averages the sample and will form the normal bell shaped distribution curve even if the original data is not normal. So in our case, if you take multiple sample of housing prices in different cities, their average will form a bell-shaped curve, regardless of whether the housing price in individual city are normally distributed or not. Or if you take a large sample of data, you will realize that the distribution will come normal. Overfitting and bias variance trade-off. Overfitting happens when a model is too focused on a specific details of a training data and does not work well for the new data. Example, like if you memorize all question for a maths test, but the test is different and you will struggle. Similarly, if a model learns every tiny details of training data, it won't do well on a new data. So bias, what is bias variance trade-off? So bias means the model is too simple and missing the important patterns, and variance means the model is too complex. So learning too much noise from random noises. Suppose in a sports team, if a coach is too strict, that is high bias, and the team always follows the same strategy and misses the opportunity. If the coach is too flexible, then it's a high variance. The team may try many different things but lack consistencies. The best teams find a middle ground on that. In our application, our complex model is like high variance and might fit training data too well but perform poorly on a new data. So we have to find the right balance with the model and generalizes well using the bias variance trade-off. And we'll see like how this bias and variance is occurring in our models. Confidence interval and the prediction interval. This gives a range within which we expect true average of the population to lie within a certain level of confidence. Example 95%. So if we say our house prices in a city is between 180k and 220k with 95% confidence, we are saying that 95% chance that true average falls in this range whenever we repeat the experiment. So, predicting the interval, it gives a range within which we expect an individual data points to lie. If we say the price of a specific house is between 200k and 250k, we are making a prediction for that one house. Using confidence interval to express the uncertainty of the average housing prices prediction, calculating the predicting intervals to provide a range of for an individual house pricing prediction and accounting for a variability, and we'll further see in our models. So EDA, exploratory data analysis. So in this part, we'll try to understand the data, like how the data varies and how data is correlated and which factor is influencing which part. So we'll first describe the data and we'll see like what are the values, like what are the factors such as price, address, and so on, and their values of it. And we'll see like what type, whether the variable is ordinal or whether the variable is nominal. So ordinal variables are bedroom, bathroom, balcony, parking, and so on. Nominal variables are address, status, furnished status, and landmarks, and so on. So data distribution. Here you can see the bell-shaped curve is between latitude and longitude, and even in the uh, prices. Like if you widespread the data and if you take a large number of data, you will find a bell-shaped curve. So unique data description, like uh, what type of addresses, what's the status, like whether to property is ready to move or whether it is an under construction or whether it is for resale or whether it is new property, and so on. We can see other type of factors also in the similar fashion. As you can see in the correlation heat map, it shows the how strongly one data is correlated with another data. As you can see, dark blue color shows the strong correlation between two factors such as price, square feet, and the price. As you can see, the number of square feet increases, price will also increase. Similarly, in the area, like how big the house is, whether the area is larger, the larger the area, larger the price. And also depends on the bathrooms, bedrooms, like how you can see uh, the strong correlation between the number of bedroom increases, number of the price of the houses will increase. As you can see, we have plotted the city map, like this is showing the geographical area and also showing the uh, plot of the area where the house is located and the description about it. The BI models. In BI models, we'll discuss and compare linear regression model, decision tree, random forest, gradient boosting, and XGBoost. So for evaluating the model performance, there are four metrics like precision, sensitivity, recall, and specificity. So one side the actual class is there, one side the predicted class is there, and the number of positives and number of negatives. So when the actual class is having the true positive and the predicted class is predicting its correctly, so it is a true positive. And when it is correctly, when it is predicting incorrectly, then it's false positive. And similarly, so another criteria to evaluate the model is ROC curve that separate the signal from the noise. And we can see in the graph that whenever it's approaching to 1, it's a perfect classifier. Whenever it's a ratio of true positive rate over a false positive rate is less than zero point 0.5, it's a uh, random classifier. So firstly, we'll discuss linear regression model. For statistical model for modeling the relationship between dependent variable and one more independent variable. So for simplicity, we are assuming a linear relationship for predicting the continuous outcome. We have created a model price, and we are seeing how square feet is affecting the price and how bedrooms are affecting the price. And similarly, we can create model in the similar fashion. As you can see in the graph, that it's showing the equation of the price and how the sample is distributed and how it's showing the random error and the observed value and the predictive value. Decision tree model. It's a hierarchical model that splits data into subset based on the features value. Each internal node represents a decision branch, represents outcomes, and a leaf node. So in decision tree, uh, it can be used for classification and regression task also. And on the basis of what are the attributes on which we decide, like this this node should split or this should not split, that is information gain and Gini impurity. What is information gain? It's a difference between entropy of parent node or the decision node and the weighted average entropy of child nodes, and it select the attribute that result in great reduction of entropy. And what is entropy? Entropy is a measure of uncertainty or impurity in a data set. So if the entropy is high, it shows data is evenly distributed, and if entropy is low, it shows data belong to the same class. And in the similar fashion, we can split the data. Random forest model, an assemble method that combines multiple decision tree to improve our accuracy, and it reduces the overfitting by averaging the results of individual trees and leading to a more robust predictions. Gradient boosting model, this is an optimization algorithm used to minimize the loss function. Loss function in machine learning models, and it adjusts the parameters to find best fit of them for the model. So what is a loss function? Loss function is a measure of performance of the model on a single training. Whereas cost function is the average loss function over all training example. As you can see in the image that I have shown the graph, like how the loss function started and how it learns through experiment by experiment, and how it comes to the minimum point of cost function, and where alpha is here is the learning rate, whereas del j upon del w is the gradient. XGBoost model, this is an optimized gradient boosting framework that enhances the speed and the performance of the model, that utilizes the decision tree in a sequential manner to minimize the errors and making it highly effective for large data sets. So what was our findings from this data set? So we have evaluated model performance on the basis of R2 score, mean square error, root mean square error, mean absolute error. So as we can see, we have taken 7 models, and we are getting best accuracy for the random forest model, where accuracy of 93.38%, using a data split of 70% training and 30% validation. So what was our findings? The average price is around 83 lakh, sorry, 8 crore 37 lakhs 50,000, and the most expensive area is like 5,313 meter square near a landmark. Basic amenities area is like 900 meter square, like most people are purchasing the 900-meter square area. The best performing model was random forest with 93.38% accuracy, and linear regression model is the worst performing model with the accuracy of 74.8% accuracy with the lowest R2 score and ROC score. Our implication as a real estate professional, what we can do with this knowledge? We can increase the property valuation, like we'll understand what are the key attributes, how this attribute is impacting the prices, and we can set the competitive prices. And similarly we can improve our client relations, like whenever we have a data driven uh, whenever we have a data driven results, we can recommend them, and we can tailored solution on the basis of uh, client criterias. And we can also enhance marketing strategies, and we can make targeted advertising, like how this particular area is having the more prices as compared to other uh, locality areas, and similar fashions. Thank you. If you have questions, you can ping me, and you can. Thank you.